Is screen visible to you? Screen కనిపిస్తుందమ్మా?
Yes,
Yes,
sir.
sir. Yes, sir.
Right. See, in the last class we have started the new topic, that is semiconductor diode laser. Okay. Actually, for the topic I have given introduction about laser. For the topic I have given introduction about laser. Okay. Then I will ask few questions regarding yesterday's topic. What is the abbreviation of laser?
Light
What is-
amplification by stimulated emission of radiation.
Right, very good. Light amplification by stimulated emission of radiation. Is it natural light or artificial light?
Artificial.
Artificial.
Light, right, good. That is artificial light. Okay. And I have explained about the characteristics of laser. How many characteristics we have?
4.
4 characteristics. Can anyone give that 4 names?
High directionality, high
Right.
intensity, monochromatic, and coherent.
Right. Okay. These 4 characteristics are high. High directionality, high intensity, highly monochromatic, highly coherence. Okay. Everyone has to remember these 4 points. This topic is very, very important in unit 4. Okay. Again, I will explain in unit 4 again, but I will explain in detail in unit 4. Okay. We have to study one by one point. What is the meaning of high directionality? Next, high intensity, highly monochromatic, highly coherence. The topic itself take minimum half an hour, 30 minutes. Okay, that I will explain in detail in the next class. Right. Then, can anyone give explanation for what is the meaning of coherence? Coherence. Can anyone have idea? Yesterday I explained. If two waves should be coherent, then what are the conditions? If two light waves should be coherent, what are the conditions?
They should have same frequency and wavelength
Right.
with a constant phase difference.
Very good. Right. Same frequencies, same wavelength, constant phase difference. If we are having these properties for two waves, we can say those are coherent in nature. Right. And is ordinary light and laser light both are same or different?
Different.
Different.
Right. Both are different. Ordinary light and laser light both are different. Generally, we can give the difference between these two based on 4 characteristics only. That 4 characteristics are high for laser or ordinary light.
Laser.
Laser.
Laser. Whatever, right. Whatever characteristics I have explained in the last class, that 4 characteristics are high for laser and that 4 characteristics are low for ordinary light. Right. And what is the principle involved in any laser?
Stimulated emission.
Very good. Stimulated emission. Now, what is the principle involved in LED?
Spontaneous emission.
Spontaneous emission.
Right. Spontaneous emission, and one more principle is there.
Electroluminescence.
Right. Very good. Electroluminescence. Okay. In LED, I explained 2 principles. One is electroluminescence. Second one is spontaneous emission. Here, the principle involved in laser is stimulated emission. Good. This everything I have explained in the last class. Can anyone can anyone explain what is the meaning of stimulated emission? What is the meaning of that? What is the meaning of stimulated emission? Anyone have idea about that? Already I explained about that one. Stimulated emission. In case of stimulated emission, where the electron should be present, ground state or excited state?
Excited.
Excited state.
Excited state, right. Is it necessary to give energy from outside?
Yes.
In case of stimulated emission, is it necessary to give energy from outside? Yes or no?
Yes.
Right.
Yes,
With then only we can say stimulated. Okay. Then in place of 1 photon, how many photons will release in stimulated emission?
2.
2 photons.
Right, 2 photons. This is everything I explained in the last class, and I also explained about I started semiconductor diode laser. How many types of semiconductor diode lasers are there?
2 types.
2.
2 types. Right. Then what are those? What are the
Homojunction,
two? Yeah,
heterojunctions.
homojunction semiconductor diode laser and heterojunction semiconductor diode laser. Very good. What is the meaning of homojunction? Both side of the junction made with same
Same
material or different?
semiconductor.
Of material.
Same kind of semiconductor, same kind of material. Homojunction means same kind of semiconductor on both sides of the junction, right? Heterojunction means? Heterojunction means?
Different type of semiconductor.
Right, different type of semiconductors on both sides of the junction. Now tell me, what is the principle involved in semiconductor diode laser? What is the principle involved in semiconductor diode laser? Remember, in any laser, principle is same. Okay, మనకు ఒకటే నమ్మ ఇక్కడ మనకి ఏ లేజర్ అయినా సరే. Okay, we are having 5 types of lasers: solid laser, liquid laser, gas laser, dye laser, semiconductor diode laser. Generally these type of lasers we have: solid laser, liquid laser, gas laser, dye laser, semiconductor diode laser. Remaining we will study in the next unit, but here we are studying semiconductor diode laser. In every laser the principle is same. What is that principle? That was proposed by Einstein. What is that?
Stimulated emission.
Right, very good. Stimulated emission. The principle involved in any laser is stimulated emission. Okay, this is the definition of homojunction. Already I explained in the last class. Heterojunction also I explained. Okay, now tell me, in which bias we have to connect semiconductor diode laser?
Forward.
Forward.
Right, in forward bias we have to connect this semiconductor diode laser, and the principle also I explained here. Okay, this complete principle I explained here. This is the circuit diagram for forward bias, and this is the direct or indirect. This diagram for direct band gap. Okay, can anyone give the example for direct band gap semiconductor? Give any one example. Can anyone give one material name for direct band gap?
Gallium phosphide.
Marketing.
Right, gallium phosphide, or any another one?
Aluminum gallium arsenide.
Right, aluminum gallium arsenide or gallium arsenide. Okay, these are the examples for direct band gap semiconductors. Here, up to here, we have studied in the last class. Okay, today we will complete this concept: semiconductor diode laser homojunction. We will complete today. And here, whatever light emitted during recombination, that won't come outside directly. If it comes directly to outside, then that is the LED. After recombination of electron and hole at the junction, then that is emitted in the form of light. If the light come outside directly, then that is LED. But here that won't come outside. What will happen? Whatever light emitted here during recombination, that stimulates the other electrons and holes to recombine. Whatever light emitted, that stimulates, that means that will help to increase the more recombinations. That is, whatever light emitted during recombination, that will help to recombine more electrons and holes at the junction. Then we will get the high power, high intensity of light. Okay, that will produce the high intensity of light. That is the principle involved in laser. Okay, today we have to study the first characteristics of this laser. Characteristics of this laser. Okay, first we have to study what are the characteristics of this laser. Then construction, working, advantages, disadvantages, and finally applications. Okay, here already principle we have studied, definition we have studied. Definition we completed, principle we completed. Next, characteristics, construction, working, advantages, disadvantages, and applications. Okay, see, what are the characteristics? These are the characteristics of this laser, semiconductor diode homojunction. See here, if you write these characters in exam, automatically the examiner will confirm that you know about this laser. Okay, automatically you will get 50% of marks. ఓకే, మీరు ఎప్పుడైతే ఎగ్జామ్లో ఈ క్యారెక్టరిస్టిక్స్ రాశారు, ఎందుకంటే ఇఫ్ యూ రైట్ దీస్ క్యారెక్టరిస్టిక్స్, దిస్ విల్ గివ్ కంప్లీట్ ఇన్ఫర్మేషన్ ఆఫ్ దట్ లేజర్. If you write these characteristics will give the complete information of our homojunction semiconductor diode laser. then automatically examiner will confirm that you know about this laser. ఓకే, ఎవరైతే మీ పేపర్ కరెక్ట్ చేస్తున్నారో ఆటోమేటిక్గా వాళ్ళు ఏమంటారంటే వాళ్ళు ఒక కన్ఫర్మ్ ఒక డెసిషన్కి వచ్చేస్తారు అన్నమాట. ఓకే, యూ నో దట్ అబౌట్ దిస్ లేజర్. ఓకే, దే విల్ డిసైడ్, దెన్ ఆటోమేటికలీ దే విల్ గెట్ పాజిటివ్ ఇంప్రెషన్, యూ గెట్ గుడ్ మార్క్స్. ఓకే, ఫర్ ఎవ్రీ లేజర్ యూ నీడ్ టు నో క్యారెక్టరిస్టిక్స్. Every laser, for every laser you need to know these characteristics. What are those characteristics? Now tell me, how many types of lasers are there? How many types of lasers are there? Total we are having how many types? Chapanamma, how many types of lasers? In semiconductor, how many types?
Two.
Two types. In semiconductor, two types, that already you know. Then total how many types? Total 5 types I told you. Solid laser, liquid laser, gas laser, dye, DYE, dye lasers. Finally, solid state semiconductor laser. Final one is solid state semiconductor laser. Total 5 types now. Solid laser, that means the active material should be solid. Liquid laser, gas laser, okay, next dye laser, and finally solid state semiconductor laser. These are the 5 types of laser. In characteristics, first we have to write the type. Is it solid or liquid or gas or dye or semiconductor? That we have to write first. Okay, then what is this type of laser? Solid, what is this type of laser? This is the solid state semiconductor laser. First type we have to write. Okay, whatever laser you are studying, what is the type of that laser we have to write first. That is the solid state semiconductor laser. Solid state semiconductor laser, that is the first one. Second, active medium. What is the meaning of this active medium? Active medium means here where the electrons and holes recombine, and in which place the electrons and holes recombine, that we can call active medium. In case of here, in case of this semiconductor diode laser, where the electrons and holes recombine, what we can call that place? Where the electrons and holes recombine.
Depletion.
Depletion.
Right, exactly. Depletion layer, that we can call PN junction. That we can call junction. That is the depletion layer, no doubt at all. Here, active medium is PN junction diode. Active medium is PN junction diode. And here, this laser we are studying homojunction. Homojunction means made with the same material. Homojunction means made with the same material. Here, active medium is a PN junction diode made from a single crystal of gallium arsenide. What is the material we are using here? Gallium arsenide single crystal. Okay, that is we are using as a PN junction diode. That gallium arsenide single crystal we can use as a PN junction diode. Active medium is the junction of that diode. Active medium is the junction of that diode. Here, where the electrons and holes recombine, that we can call active medium. A PN junction diode made from a single crystal of gallium arsenide. Here, that is the PN junction of the diode is the active medium that we can made from a single crystal of gallium arsenide. Next, pumping method. Pumping method means how we can give energy to the system. How we can give energy to the system? By applying light from outside or electric discharge. That means the electrons are giving energy or the light is giving energy to the system. In which method we are following? Here, pumping method is the direct conversion method. What is the meaning of that? Why we are calling direct conversion? Why we are calling direct conversion means if the electron and hole recombine, if the electron and hole recombine, that directly converted into light. Here, in case of direct band gap semiconductor, electron and hole recombine at the junction, that is directly converted into light. Avuna kada? Yes or no?
Yes.
Okay, that's why we are calling direct conversion method. Okay, pumping method means how we are supplying energy to the system. Here, the electron and hole recombine, that is emitted in the form of light. Okay, that light is not coming outside directly. What that doing? That during recombination, whatever light coming out, that stimulates the more number of electrons and holes to recombine. Okay, that stimulates the more number of electrons and holes to recombine. That means whatever light we are getting due to recombination initially, that light energy only used to stimulates the more number of electrons and holes to recombine. That's why the pumping method we are calling direct conversion method. That means from outside we are not supplying any energy to the system. Remember, just we are connecting in forward bias. That's enough. Whatever semiconductor diode laser we are taking, that we are connected in forward bias. Okay, and after connecting in forward bias, at the junction the electrons and holes recombine. That is emitted in the form of light. That light only we are using to stimulate the more number of electrons and holes to recombine. That's why we are calling the direct conversion method. Okay, direct conversion method is the pumping method here. And next one, power output. Okay, finally whatever laser is coming out, what is the power of that laser? What is the power of that laser? That is the 1 milliwatt. That is 1 milliwatt. What is 1 milli? Milli means 10 to the power
-3.
-3, right? That means whatever output power we are getting here, that is 1 milliwatt. That means that is less, no doubt at all. Compared with other lasers, the output power is less, very less. And fifth one is the nature of output. Fifth one is the nature of output. Here two possibilities are. Generally laser will come out in two ways. That may be continuous light or pulsar light. Continuous light means there is no gap, complete straight line you will see. Okay, continuously we will get. Pulsar means first we will get some light, then some gap, again light, again gap. That means that is coming out in the form of pulses. That is coming out in the form of pulses. Okay, in between gaps are there. That is pulse. Both are possible here. In case of homojunction, both are possible, continuous wave or pulsed wave. Then what is the wavelength of output laser? Okay, whatever light finally we are getting output, what is the wavelength of that one? That is the in between 8300 angstroms to 8500 angstroms, in between this. Okay, this is the complete characteristics of this laser. This is the complete characteristics of this laser. For every laser, first we have to write this one. First definition, after that principle, then you have to start with the characteristics. If you write the characteristics, then automatically remaining portion, the examiner will decide, you know, about the topic. Automatically, he will get the positive impression on you. Okay. Now, in this case, what is the type of laser? What is the type of this laser?
Solid state.
Solid state.
Solid state semiconductor laser. Solid state semiconductor laser. And the active medium means what I told. What is the meaning of active medium? What is the meaning of active medium?
Where the recombination takes place.
Very good. Where the recombination takes place. That is called active medium. In case of this one, the place is PN junction. A PN junction diode made from a single crystal of gallium arsenide. And what is the pumping method we are using here? What
Direct conversion.
Right, direct conversion method. Then what is the output power?
1 milliwatts.
1 milliwatt. Then what is the nature of output?
Continuous or pulsed.
Right, that may be continuous or pulsed. Then what is the output wavelength? That is in between
8300 to 8500.
right. Everyone has to remember these characteristics. Remember, for whatever lasers you are going to study in future also, these characteristics you have to know. Okay, these characteristics will change from diode, the laser to laser. Okay, now this is the homojunction. Now we will compare with the heterojunction. Now here itself we have to say what are the characteristics of heterojunction. Okay, that I will explain in the next class, but we will compare here itself. See, homojunction, heterojunction, both are semiconductor diode lasers, no doubt. Homojunction and heterojunction both are solid state semiconductor diode laser. Now tell me, in case of heterojunction, what is the type? In case of heterojunction,
Solid state
what is the type?
semiconductor.
Right, same solid state semiconductor laser. Now tell me, what is the active medium in case of heterojunction? Anyone can guess? PN junction diode, no doubt. In both cases, the active medium is PN junction diode, but that is made from same material or different material?
Different material.
Right, that is made from different materials of semiconductors. Okay, that is the active medium. Pumping method is also same. What is the pumping method in heterojunction?
Direct conversion method.
Direct conversion, that is same for both. Then what is the output power? That is also same. What is the output power?
1 milliwatt.
1
1
milliwatt.
millivolt. 1 milliwatt. 1 milliwatt anamata. Okay. In case of heterojunction also 1 milliwatt. But nature of output will be different. In case of homojunction, we can get continuous or pulse. Both are possible. But in case of heterojunction, only continuous waves are possible. Okay. There is no possibility of pulsed. Only continuous waves we will get. Then wavelength of output is also little bit different. In case of heterojunction, that is 8,000 angstroms. That is 8,000 angstroms. Actually, these two lasers again I will explain in next unit. Okay, just in for comparison point of view, I will give final table whatever lasers we are having. For all the lasers, I will give one table. In that, these 6 parameters will be there. For all the lasers, we have to know this. Finally, I will give the table after completing all lasers. Okay, these characteristics we have to remember. Okay, these are the characteristics we have to remember. Right. Next, we will start construction. We will start construction. This is the diagram for the construction of semiconductor homojunction, semiconductor diode laser of homojunction. Right. Here, how we are constructing this one. See, actually, this is the diagram for homojunction semiconductor diode laser, and it is made with single crystal of, and here active medium, whatever active medium we are taking here, that is made with single crystal of gallium arsenide. Here, the active medium is made with single crystal of gallium arsenide. Already I explained in previous slide. And how we have to cut this one, how we have to cut the semiconducting material, how we have to cut that single crystal. Okay, here the active medium is made with single crystal of gallium arsenide. That's no doubt. Then this single crystal we have to cut in the form of platelet. This single crystal we have to cut in the form of platelet with a thickness of 0.5 millimeter. Remember, here this semiconducting material we have to cut in the form of platelet. Platelet is just small cube. Platelet means small cube with thickness of 0.5 millimeter. Okay, whatever single crystal of gallium arsenide we are taking, that we have to cut in the form of platelet. Platelet means that is in the form of cube with small thickness. Okay, the thickness having around 0.5 millimeter. 0.5 millimeter. That platelet consists of both the regions, P type and N type. That platelet consists of both P type and N type regions. And the upper and lower surface of the semiconducting material having the metal electrodes. This is the one electrode and this is the second electrode. This is the second electrode. Now, how we are connecting this one? This is connected to the battery in forward bias or reverse bias?
Forward bias.
Right, we are connecting here in forward bias. Okay, and what is the semiconductor we are using here? Is it direct band gap or indirect?
Direct band.
Right, direct band gap semiconductor only. Okay, this is the construction here. And one more point you have to know, that is where the electrons and holes recombine at the junction. Where the electrons and holes recombine, that is at the PN junction. Okay, then after recombination, what we will get? Light will come out. Okay, after recombination, direct the light will come out. That is not laser. Remember, after recombination of electrons and holes, if the light is coming out, that is not laser. That is LED. Okay, at the junction after recombination of electrons and holes, the light is coming out. That is LED, not laser. Here, what's happening? Here, whatever light emitted after recombination, that is not coming out. What that will do? That stimulates the electrons and holes recombine. Whatever light emitted during recombination, that light again stimulating the electrons and holes to recombine. More number of electrons and holes to recombine. Then automatically the intensity of light will increase inside. Then that is coming out. How that process will happen inside, that we have to know. How that process will happening here. For that, you need to know the main parts of the laser. For any laser, not only this. For all the lasers, what are the main parts? Every laser having 3 parts. Every laser having the 3 parts. Already we have studied about 2 parts. What are the 2 parts? First one is the active medium. In any laser, active medium is there. In any laser, active medium is there. That is the first part. Already we have studied. Second one is the pumping method, pumping mechanism. that also we have studied. Okay, pumping mechanism, direct conversion here, that also we have studied. Third one we can call optical resonator. Remember, in case of laser, any laser, we are having the three parts. First one is the active medium, second one is the direct conversion, third one is the optical resonator. First, active medium and pumping method already we have studied in characteristics. Then what is meaning of optical resonator? Optical resonator means, okay, in this diagram I will explain. See, this is the PN junction for the semiconducting material. Okay, this dotted lines, between these dotted lines, that is the PN junction. The light is coming out from here. The laser light is coming out from here. Resonator means, optical resonator means, that is having two mirrors. That is having two mirrors. One is 100% reflector, second one is partial reflector. Okay, every resonator having two mirrors, one is the 100% reflector, second one is the partial reflector. Why we have to take like that? What is the reason behind that? See here, this is the PN junction diode. Now what we have to do? We have to polish this PN junction diode. We have to polish this PN junction diode. One side, that is the acting as a partial reflector, exactly opposite of this one having a 100% reflector. Remember, one side is partial reflector and another side is 100% reflector. Now tell me, how many sides of the junction here? Okay, this is the Q. This dotted lines, between dotted lines we are taking as a junction. How many sides of the junction are there? How many sides are there for this junction? Now you are seeing on the screen only two sides. This is one, this is the second one. Okay, where the light is coming from, that is the second one side, and this is the first side, exactly opposite to you. Then remaining any other side, how many sides for this? We are having total four sides. Remaining two we can't see because this is the 2D diagram. Okay, this is the 2D diagram. Remaining two sides should be back side. Okay, this is one side, this is second side, and here we have to polish two sides. One is partial reflector, this is the partial reflector, we have to coat it like that, we have to polish it like that. Exactly opposite of this one is 100% reflector, exactly opposite of that one, that is 100% reflector, but we are not seeing now. That 100% reflector side we are not seeing, that is exactly opposite to this one. Okay, why we have to do like this? What is the purpose of doing this polishing? 100% as 100% reflector and the partial reflector. The reason is, whatever light coming here after recombination, that light will bouncing forth and back between two reflectors. One is the 100% reflector, second one is the partial reflector. After recombination at the junction, whatever light radiated, whatever light emitted, that is not coming out directly, that is making bouncing forth and back between the reflectors. When that is bouncing forth and back, in that case, that is making more stimulates, that is making more stimulates of electrons and holes to recombine. Then automatically the strength of intensity of light will increase, the intensity of light will increase. The main purpose of polishing that one is to increase the stimulations. Okay, to increase the more number of recombinations. Due to that polishing, one will act as a 100% reflector. Polishing in the sense just coating, you can make with paint, that may be black color or any other color. Okay, polishing in the sense we have to make with paint. Okay, one will act as 100% reflector, another one is act as partial reflector. After making more bounces, that will make bounces forth and back, then that stimulates the more number of electrons and holes to recombine. Then after achieving our required amount of light, that is coming out in the form of laser, that is coming out in the form of laser. This is about construction, this is about construction. Okay, what we are taking here, once again I am going to explain here. This is the diagram for the construction of homojunction semiconductor diode laser. Here the active medium is the PN junction diode of that is made with single crystal of gallium arsenide. Here the active medium is a PN junction diode that is made with the single crystal of gallium arsenide, that we have to cut in the form of platelet having thickness of, and thickness undalama. What is the thickness we have to cut? What is the thickness we have to cut the single crystal?
0.5 mm.
0.5.
Right, 0.5 mm. Okay, we have to cut this platelet, this single crystal as platelet with having thickness of 0.5 mm. This platelet consists of both the regions, P side and N type. Okay, both the P region and N region. and the upper and lower surface of the semiconductor having two metal electrodes. That metal electrodes are connected to battery in forward bias. Okay, then the recombination takes place at the junction. The recombination takes place at the junction that is very thin. Actually, the complete material itself 0.5 thickness. The complete material itself 0.5 millimeter thickness. Then in that the junction thickness is very small. In that the junction thickness is very small. Here the recombination takes place. Then we after polishing this one side will act as a 100% reflector, and the second side will act as a partial reflector. After more reflections with the reflectors, then after achieving our required light, that is coming out in the form of laser. Okay, now we will check one by one point. First one, the construction of homojunction semiconductor laser is shown in figure. This is the diagram. And the active medium is a PN junction diode made from a single crystal of gallium arsenide. Okay, here this is the active medium, that is the PN junction diode made from a single crystal of gallium arsenide. And this crystal we have to cut in the form of platelet having thickness of 0.5 mm. Here platelet is nothing but small cube. Platelet is nothing but small cube with a thickness of 0.5 millimeter. Okay, this crystal is cut in the form of a platelet having thickness of 0.5 mm. Then this platelet consists of both the regions. This platelet consists of two regions, N type and P type. Okay, already we know this. Next, here two metal electrodes we are having. The metal electrodes are connected to both upper and lower surfaces of the semiconductor diode. This is the upper surface and this is the lower surface. Then we have to apply forward bias through these metal electrodes. The forward bias voltage, this one, is applied through metal electrodes. Right? Next, then after recombination, where the recombination takes place at the junction, that is very thin layer of PN junction. Now the photon emission is stimulated in a very thin layer of PN junction. Okay, whatever light emitted here, that won't come directly. If that will come directly, then that is LED. Okay, that won't come outside directly. That stimulates the more number of electrons and holes. That stimulates more number of electrons and holes to recombine. That okay, that's one. And what we have to do here, the end faces of PN junction are well polished. Okay, the purpose of that one is we need more reflections between the walls. After more reflections, that stimulates more number of electrons and holes, that will act as an optical resonator. Check the last point. The end faces of the PN junction are well polished. The end faces we have to polish well and parallel to each other. The end faces are parallel to each other. Then this will act as an optical resonator through which the emitted light comes out. Okay, from that only the laser output will come. Okay, this is about the construction. Next, working. Working as it is LED. Diagram also same. Check. This is the working energy level diagram. Is it same with the LED or not?
Yes.
Yes, sir.
Okay, whatever working energy level diagram we have studied in LED, same diagram almost. Just what will change? Only principle will change. In case of LED, the principle is spontaneous emission or electroluminescence. Here, the principle is stimulated emission. That only difference. Remaining working is everything will be same. In LED, what after recombination, the light will come out directly. But here, that won't come directly. That stimulates the more number of electrons and holes to recombine. That only difference between these two. Okay, this upper one is the conduction band, that is having more number of free electrons, and lower one is valency band, that is having more number of free holes. Okay, and here the Fermi level they have not represented. In case of N-type semiconductor, where is the position of Fermi level? In case of N-type semiconductor, where is the position of Fermi level? Can anyone give the answer? Where is the position of Fermi level in case of N-type semiconductor?
Near to conduction.
Right, that nearer to conduction band. In case of P-type semiconductor?
Near to valence band.
Right, nearer to valence band, right. Okay, and between this valence band and conduction band, we are having the band gap. Then when we connected in forward bias, automatically more number of electrons in conduction band, more number of holes in valence band. More after connecting in forward bias, the electrons from conduction band and holes from valence band both recombine at the junction, that is emitted in the form of light. That is emitted in the form of light, laser light. Okay, that won't come directly. whatever light initially emitted, that stimulates more number of electrons and holes to recombine. Now we will check one by one points. See here, this is the forward bias PN junction diode. The energy level diagram of homojunction semiconductor diode is shown in figure. That is previous diagram. When the PN junction is forward biased, the electrons and holes are injected into junction region. Okay, here this is the PN junction diode. This we have connected in forward bias. That means positive region of PN junction diode is connected to positive terminal of the battery, and the end region is connected to negative terminal of the battery. Between these two positives, repulsion is there. Between these two negative, repulsion is there. Okay, due to that, what will happen? The holes are trying to cross the junction. The electrons are also trying to cross the junction. If the applied voltage is equal to barrier potential, then the electrons and holes starts crossing the junction. That means this one. When the PN junction is forward bias, the electrons and holes are injected into the junction region. There is only possible the applied potential is greater than or equal to barrier potential. Remember. Okay, when this injected into the junction region possible, the applied potential should be greater than or equal to barrier potential. Below that one, there is no chance of crossing the junction. Okay, right. Next, the region around junction contains large number of electrons in conduction band and holes in the valence band. Okay, this is the junction. Around this one, we are having the large number of electrons in conduction band. N type we can call as a conduction band, and P type we can call as a valence band. Large number of electrons in conduction band and large number of holes in valence band. Now the electrons and holes recombine each other. Okay, at what point? At PN junction or in depletion laser region. During this recombination, what will emit? Light photons will be produced. Light photons will be produced. Here we can increase the light intensity. Okay, how we can increase the light intensity here? By increasing the diode current voltage here. By increasing forward biased voltage, then we can increase the more number of light photons. Okay, you can check the last point. When the forward biased voltage is increased, then automatically that will increase the more light photons. Okay, when the forward biased voltage is increased, more light photons are emitted. Okay, then that photons won't come directly. That will stimulate the electrons and holes to recombine again. More number of electrons and holes to recombine. Okay, these photons trigger a chain of stimulated recombinations. Okay, that will help to recombine more number of electrons and holes, resulting in the emission of more light photons in phase. Okay, that we can call laser light. Then what will happen? Whatever photons are coming during recombination, these photons moving at the plane of junction travel back and forth by reflection between the two polysil surfaces of the junction. That only we are calling optical resonator. Between those two polysil surfaces, these light photons are bouncing forth and back. That means moving forth and back by using reflections. Thus, the light photons grow in strength automatically. When those are doing bouncing forth and back, automatically that stimulates more number of electrons and holes to recombine. Then automatically that light photons grow in strength. Okay, right. Then after gaining enough strength, whatever laser beam is emitted, the wavelength of that laser beam is 8,400 angstroms. Okay, generally in characteristics we have given that is in between 8,300 to 8,500. Okay, here the value we are saying that is 8,400 angstroms. Okay, then how can we calculate that wavelength? Already you know this formula. Okay, we can calculate a wavelength by using this formula. Energy band gap is equal to h nu. Then what is the formula for nu? Nu equal to c by lambda, then hc by lambda, then lambda equal to hc by eg. This is the formula we are using for calculating the wavelength of the outcome laser light. Okay, laser outcome. This is about working. Already we know about this. Already maximum we have studied in LED. Only difference is stimulated emission. Okay, due to stimulated emission, the light won't come directly outside. Okay, that stimulates more number of electrons and holes to recombine. Further, that is traveling back and forth by reflection between the two polysil surfaces of the junction. That will increase the strength of the light photons. This is the working. ఇందులో ఎవరికి డౌట్ ఉందమ్మా? కన్స్ట్రక్షన్ కానీ వర్కింగ్ కానీ? ఎనీ డౌట్ ఇన్ కన్స్ట్రక్షన్ అండ్ వర్కింగ్?
No, sir.
right? Then we have to study advantages, disadvantages, and applications. What are the advantages of this one? Okay, first one is this laser is very small in size and compact. Already I told starting slides in semiconductor diode laser. This semiconductor diode laser, okay, this is very small in size and compact. We can keep in our pockets also. Okay, we can keep in our pockets. That is very small in size and compact. And second advantage, it has very high efficiency. It has high efficiency. High efficiency means whatever light we are getting in recombination, that maximum utilized in the form of laser output. Okay, that means we can call that is high efficiency. Efficiency we can calculate by using output by input. Output optical power by input optical power, that we can call efficiency. This semiconductor diode laser having high efficiency. That means the losses are less. The losses are less here. And what are the other advantages? Here we can increase the laser output by increasing the junction current. If you increase the junction current by increasing the forward voltage, first you can increase the forward voltage, then that will increase the junction current, then automatically laser output you can increase it easily. Okay, the laser output can be easily increased by increasing the junction current. By increasing the junction current, we can easily increase the laser output. And whatever power we are using here for operating this one, okay, the power we are applying here for operating this one, that is less compared with the other lasers. That is less compared with the other lasers. Other lasers means solid laser, liquid laser, gas laser, dye laser. Examples they given here: ruby laser and CO2 laser. Ruby laser is example for solid laser. CO2 laser is an example for gas lasers, carbon dioxide laser. Okay, and the operating power for semiconductor diode laser is less than ruby and CO2 lasers. It is operated with less power than ruby and CO2 lasers. And next point, whatever equipment required for this laser, those are very little. Whatever equipment required for making this laser, those are very little. It requires very little additional equipment. It requires very little additional equipment. And another advantage is by using this one, we can get both light waves, continuous and pulsed. Both output we can get. These are the advantages. These are the advantages of this laser. Then what are the disadvantages? Disadvantages are mainly every laser, generally characteristics of laser we have studied initially. We are having four characteristics: high directionality, high intensity, highly monochromatic, highly coherence. These characteristics are not high for this laser compared with other lasers. Remember, compared with other lasers, these characteristics are not high. But compared with LED, that is high, no doubt. Compared with LED, these four characteristics are good for this laser compared with LED. But compared with other lasers, these four characteristics are less. Check this one. Laser output beam has large divergence. Large divergence means just you can take one semiconductor diode laser as a PPT presentation. When we are using a pointer for PPT presentation, that laser, you can increase the distance between the wall and laser. You can increase the distance between the wall and the laser, then automatically the diameter of the spot will increase. Okay, if you can increase the distance between laser and wall, that will increase the diameter of the spot. That means that is having large divergence. Actually, for other lasers, divergence is zero almost. For other lasers, divergence is zero. Okay, you can take other lasers like ruby laser or CO2 lasers they given here. You can use ruby laser or CO2 laser. Even you can increase the distance between the wall and laser. The spot diameter that won't increase. Single spot, single diameter only we can absorb to kilometers. But in case of this one, semiconductor diode laser, if you increase the distance between wall and laser, the diameter of the spot will increase. That means that will give more divergence. That is one of the disadvantages. Laser output beam has large divergence. The purity and monochromacity are pure. The purity and monochromacity are pure, and it has poor coherence and stability. It has poor coherence and stability. That means whatever characteristics we are having the lasers, that is less compared with the other lasers, that is good compared with the LED. Okay, that means we can say this is the upgraded version of LED. This is the upgraded version of LED, but principle little bit change. Okay, then what are the applications? What are the applications where we are using here? See, these are the applications. First one, we can use in optical fiber communication. See, even LED also we can use. LED also we can use in optical fiber communication. Even this semiconductor diode laser also we can use in optical fiber communication. This first diagram, this one, this will give the diagram for optical fibers. These are all optical fibers. Okay, inside they are having lot of optical fibers. This is the laser light. Okay, this semiconductor diode laser we can use in optical fiber communication. Even LED also we can use in optical fiber communication. And the second one, it is used in laser printers. Okay, generally whatever printers we are using nowadays, everything is laser printer only. Okay, whatever printers we are using now, those are laser printers. Can anyone know what is the before version of laser printer? Before laser printer, what we used for printing purpose? Can anyone know? Before laser printers, what type of printers we used? Nowadays also some people are using those printers that we can call inkjet printers. What is the difference between these two? In laser printers, we can print more number of papers per minute. Minimum 12, 20, 30 also we can print sometimes. Okay, depending on quality of the printer. More number of papers we can print in minute. In case of inkjet, for printing one paper, it will take 1 minute. In case of inkjet, that will take 1 minute for printing one paper. Okay. Before laser printers, we used the inkjet printers. Nowadays, in some places, in color printers, they are using inkjet. But this semiconductor diode laser, we are using in laser printers. And CD writing and reading. Can anyone know about CD? Everyone choose CDs? Can anyone know about CDs?
Yes, sir.
Okay, actually nowadays we are not using, but before 5 6 years, actually that time pen drive cost is very high. Before 7 8 years, not 5, before 7 8 years, okay, before 7 8 years, the pen drive costs are very high. But that time for storing the data, we used only CDs and DVDs. CD means that store data 1 GB. CD means that store data 1 GB. DVD means that store data 4 GB. DVD means that store data 4 GB. Now we are downloading the movies. If you want to watch in other systems, just we can take in pen drive. We are watching even on directly also we can see, or if you want to see in other systems, we are taking in pen drive. We are seeing. But before 7 8 years, we are having CDs. We have to write that movie in CD. Then that CD player we are using. Even nowadays, the laptops not having CD drive. Okay, my laptop actually I purchased in 2013. I am using laptop 2013. My laptop having the CD drive. In your laptops having CD drive. Okay, whatever
No,
laptop you
sir.
are using, unda CD drive unda leda.
No, sir.
No, sir.
No, because nowadays we are using pen drives. Actually, nowadays whatever laptops we are getting, they don't have CD drive. Okay, but previously my laptop I purchased in 2013. That is having the CD drive. That time we used the CDs and DVDs. Okay, and third application, it is used to reel the wounds by infrared radiation. Okay, this laser light also used to heal the wounds. Okay, and also we can use it as a painkiller. These are the main applications. These are the main applications. Okay, right. Next, these are also other applications I have given here: laser diodes, material processing, optical sensing, healthcare, optical pumping. These are all applications of this laser. Right. See, in next class I will explain about the heterojunction. See, if you read once again, already I have sent this one. Already I have sent this material in Google Classroom. Just you can revise it. If you revise that one for tomorrow's class, it is very easy. Same thing I will explain once again, but I will finish fast in tomorrow's class. Because if you know about homojunction, that we can finish in 10 to 15 minutes. That we can finish in 10 to 15 minutes. Only construction little bit different. Remaining everything same points you will study in heterojunction. Okay, already I have sent this PPT. Just you can revise once. Then for tomorrow's class, that will be very easy. And tomorrow I will start solar cell also. In tomorrow's class, I will start solar cell also. And I have sent one table for LED experiment. In today's lab, we have to do LED experiment. In today's lab, we have to do LED experiment. For that LED experiment, I have sent one table, PDF form. About that table, in today's lab, I will explain. Okay. and around 25 to 30 students have sent that Hall effect experiment. Remaining also have to send as early as possible. Remaining students also. Okay. After the lab, I will analyze who are sent. That is, I will check once again. Okay. After today's lab, I will check the roll numbers who have sent, and remaining students also in this week as early as possible. Okay. In this week, by tomorrow, you can send that one also. Because today I will explain one more lab, LED. Okay. Then it will be difficult to you. If you have more experiments, then that will be difficult to you. Yeah, any doubts in this topic? Now doubts on my topic lo?
No, sir.
Okay, guys,
No,
the
sir.
topic? Right. Afternoon I will take the lab. Okay? Okay,
Thank you, sir.
Namanda. Bye.
Thank you, sir.
Sir.